Okay, guys. So today you are mixing all the formulas together that you learned, yeah? So every problem will be one of these three formulas, and you have to determine which of the three it is, yeah? So let's just remind you guys the three formulas, and then let's just kind of pick which one you would use in different situations, and that should get you going. So this is going to be 5.3, and I'm just calling it the mix-up, you know, because we're mixing all the conservation of momentum stuff up. Okay, so remember the three formulas are an elastic collision, which means bounce. And then we have an inelastic, which we said means stick, right? And then we have, I'm going to put dots instead of equal signs. And then we have the explosion ones, right? And that's really a form of inelastic. Okay, so elastic. So if they bounce, remember that is mv plus mv equals mv plus mv. And I'll come back and I'll put all the subscripts right now. Remember, the left-hand side always represents before the collision. Right-hand side always represents after the collision. Okay? Now let's do the inelastic. That means that they're separate from the start, but then they stick together afterwards and they have the same velocity. Okay, now the explosion means that they're stuck together at the start and they have the same velocity, which typically is 0. And then they explode and they separate from each other. That's why they each have their own momentum. So remember, this is before, this is after. Now let's put all those subscripts. This is M1, M2, M1, M2, M1, M2. And these are all initial velocities, right? And then here, this would be the initial velocity of the first one, the second one, the first one, the second one. And that one's just the initial velocity of both of them because they have the same velocity, right? Okay, let's do after the collision. We got M1, M2, M1, M2, M1, M2. And then you have, after the collision, they're going to be the final velocities instead of the initials, right? And these are all finals, okay? Now let's just write some subscripts on these. That's the first ball, the second ball, or object, really. And then the final velocity here is just for both of them, so I don't need to put a 1 or a 2. And this is of the first object and the second object. So there's our two our three formulas, okay? Let's give a couple examples here. Let's say you have an astronaut. This is a beautiful astronaut. And he's holding like a hammer or something. Okay, this is my horrible attempt at a hammer. And let's say he's stuck in the space station. He can't reach anything, right? Everything's too far away from him. How can he move? Well, he could throw the hammer, right? He could throw the hammer, and then he would move backwards at a much smaller velocity than the hammer, since the hammer's velocity was so much smaller than him. And I might ask you to calculate, like, what is the velocity of the man afterwards? So what type of one of these is that? So the two masses begin stuck together, and then he throws it, right? So that's going to end up being an explosion type formula. You would use something like that. Yeah? Let's give another example of one of them explosion ones. Let's say you got like a gun, and you have a bullet inside. Okay, it's going to fire. The bullet's going to shoot that way, and the gun's going to recoil that way a bit, right? The masses were stuck together, and they had the same velocity of 0 at the start. Remember, this one had the same velocity of 0 at the start, the astronaut and the hammer. And then after the explosion, you had two separate masses going in their own directions. Okay? Let's do another example here. Let's say you got a sumo wrestler. You got two sumo wrestlers that are going to battle each other. Yeah? You know you guys are loving these great images I draw. Okay, they're going to run into each other, and they're going to hit each other and collide and stick together, and like they're going to fly in one direction. It looks like I made this guy bigger. So like, let's say they're running at each other. They're going to collide, and then you got these two sumo wrestlers collided together. They're like in a hug, I guess. I don't know what I'm doing here. And they fly together in one direction. Yeah? What would that be? So they stuck together, right? So they had their own momentums at the start, but then they stuck together and went in one direction. So that would be a sticky collision. Yeah? Okay, and then the elastic ones, I feel like that's the easiest ones. Let's say you got like I don't know, I mean the ball situation is the easiest. Like let's say you're playing pool, some billiards, you hit the balls at each other, they collide, and then they bounce off of each other in different directions, or maybe even one bounces off at a very fast velocity while the other bounces off at a very slow velocity and they're in the same direction. That could be possible. That would be elastic. Yeah? And that's all of them. So go through the worksheet. I hope it makes sense, and have a great day.